Okay, so from the previous class, in the previous class we see up to conduction and convection process. Now radiation process. So first of all, in radiation process, no medium required and no movement of mass. Secondly, in radiation process, all bodies at a time absorbed as well as radiate energy. If the absorption energy is greater than radiation energy, then the process is called heating. If the energy radiate is greater than energy of absorption, then the process is called cooling. The very good absorber or very good emitter, a very bad transmitter, very bad reflector. Black and rough surfaces are very good absorber and very good transmitter. Similarly, shiny and smooth surfaces are very good transmitter and reflector. अच्छा, आप देखो इस रेडिएशन में सबसे पहले हम लोग को जो पढ़ना है that is न्यूटन्स लॉ ऑफ कूलिंग. न्यूटन्स ने एक रिलेशन दिया था जहाँ पे टेम्परेचर जो है Ts is the surrounding temperature plus e to the power minus bt. ये जो e to the power bt है ये एक्सपोनेंशियली डिक्रीज करता है, जिसका मतलब है according to Newton's law, if this is my temperature of anything and it is falling exponential uply up to the surrounding temperature, So this graph is very important. अच्छा, इस ग्राफ के साथ साथ इसके न्यूमेरिकल्स भी आता है. So to solve numerical, you have a different formula. The formula is T2 minus T1 by T, that is K T average minus T surrounding. This is the formula. Now I just show you one question, then you understand this, how you solve this type of question. The temperature of a body falls from 90 degrees centigrade to 80 degrees centigrade in 5 minutes. 90 degree to 80 degrees centigrade in 5 minutes, and surrounding temperature is 25 degrees centigrade. Surrounding temperature is 25 degrees centigrade. When time taken to fall the temperature from 80 degree to 70 degrees centigrade. So देखो, it's a very simple question. Temperature difference 90 and 80. So 90 minus 80 is 10. Time is 5 minutes. K you don't know. T average 90 and 80. The average is 85 minus surrounding temperature is 25. So what you have, 2 equals to K into 60. That means K equals to 1 by 30. As K equals to 1 by 30, so if we move from 80 to 70 degrees centigrade, 10 by you need the time, that is K, that is 1 by 30. T average, that is 75 minus 25. So when you solve this, what you have, T is equals to 10 into 30 by 50. 30 5 6 मिनट. एक चीज देखो, सेम रेंज पे जितना टेम्परेचर सराउंडिंग टेम्परेचर का आसपास आ जाएगा, टाइम विल टेक मोर. ओके, टाइम विल टेक मोर. ये हुआ तुम्हारा न्यूटन्स लॉ ऑफ कूलिंग. ये हुआ तुम्हारा न्यूटन्स लॉ ऑफ कूलिंग, इसके साथ है स्टीफेंस लॉ। नेक्स्ट स्टीफेंस लॉ। स्टीफेंस लॉ में क्या बोला है कि रेट ऑफ फ्लो ऑफ हीट per unit time is directly proportional to T to the power 4 into cross section area. Radiant energy per unit time या rate of flow of heat per unit time is directly proportional to T to the power 4 A. So when we equalize, we use a constant. When we equalize, we use a constant. When we equalize, we use a constant. That constant is called sigma. Sigma A sigma A T to the power 4. So when we use a constant, that is called sigma A T to the power 4. Sigma is a constant, it's called Stephen's constant. The value is 5.67 10 to the power minus 8 watt per meter square per Kelvin to the power 4. So on that basis, now this is one part. अब इसमें से एक और बात देखो कि this is for Stephen's law for perfectly black body. Black body. But not a body is perfectly black, because a perfectly black body में क्या होगा, the amount of heat absorbed by the body is equal to the amount of heat emit by the body instantly. मतलब जितना heat absorb करेगा उतना ही heat तुरंत emit कर देगा, ठीक है. But perfectly black body is not possible. So as the perfectly black body is not possible, हम लोग यहाँ पे एक और टर्म लेता है dq by dt सिग्मा ई ए टी टू दी पावर 4. इस ई को बोला जाता है एमिसिविटी, इस ई को बोला जाता है एमिसिविटी. The value of E is neither 0 nor 1. It in between 0 to 1. ठीक है. So this is Stephen's law. And by using this Stephen's law, we can solve some questions. Is it okay, everyone? First question. देखो, a black body is maintained at 27 degrees centigrade and at 927 degrees centigrade. Okay, what will be the ratio of the radiant energy? First of all, one very important thing, this temperature is always the Kelvin scale. This temperature is always the Kelvin scale. So the ratio of the radiant energy, that means dq by dt, if you write 2 by dq by dt, if we write 1, that is directly proportional to the power 4, temperature to the power 2 by temperature to the power 1 to the power 4. Kelvin scale 927 plus 2733 is almost 1200, and this is 300 square, that is 4 to the power 4. 4 to the power 4 is how much? 1 by 256. Okay, everyone, is it okay? Hello. Next question. Next question is, okay, next question is, the temperature of the black body is increased by 50%. Temperature increased by 50%. Suppose temperature of a black body increased by 50%, then the percentage increase in radiation, energy is approximately, तो देखो हम क्या लिखेंगे, रेडियंट एनर्जी dq by dt is directly proportional to t to the power 4. We know that. So if we write dq by dt 2 by dq by dt 1, that is t2 by t1 to the power 4, 50% increase means 1 become 1.5 t by t to the power 4, that is 1.5 to the power 4, and 1.5 to the power 4 is 5.06. So dq by dt2, that is 5.06 dq by dt1. So dq by dt2 dq by dt1 by dq by dt1 into 100, that is 5.06 minus 1 by 1 into 100, like this. So 406% is the answer. So this type of question examiner can ask you. Okay, next question is okay. Next question is two spheres of same material having radii having radii 1 meter and 4 meter, 1 meter and 4 meter, and temperature 4000 Kelvin and 2000 Kelvin respectively. Two spheres of the same material having radii 1 meter and 4 meter and temperature 4000 Kelvin and 2000 Kelvin respectively. Find the ratio of radiant energy per second by the first sphere to that of the second sphere. So radiant energy dq by dt, as the area is given here, is directly proportional to area into t to the power 4. So dq by dt2 by dq by dt1, that is a2 t to the power 2 a1 t to the power 1 4, that is 4 pi r2 square 4 pi r1 square t to the power 2 square t to the power 1 square, that is r2 minus 4 square 1 square 2000 square, sorry 4000 square 2000 square. So what you have ulta likha, sorry, t2 is 2000 square and this is 4000 square. So what you have, this is 0 0 cancel first of all, so you have 4 into 4 2 to the power 4 4 into 4 into 4 into 4, this cancel, so 2 into 2 into 2 into 2 4 into 4, that is 1. So the ratio is 1:1. Okay. So the next question is Wien's displacement law. WIEN apostrophe S. Wien's displacement law. So what is Wien's displacement law? When a body is heated, it emits radiation of all wavelength. When a body heated, it radiates wavelength of all radiant. Okay. However, the intensity of radiation of different wavelength is different. According to Wiens, the product of the wavelength corresponding to the maximum intensity. Yes. देखो क्या होता है कि कोई भी ऑब्जेक्ट हीट रेडिएट करता है फॉर डिफरेंट इंटेंसिटी डिफरेंट वेवलेंथ. So according to Wiens, this law is specially used to measure the temperature of the stars or any planet. So for that, suppose we are put a receiver on the earth, okay, where for different intensity waves are received. For different intensity, the wavelength is different. Wavelength corresponding to maximum intensity. Try to understand. Wavelength corresponding to maximum intensity, that wavelength is called the lambda m. The wavelength corresponding to maximum intensity and the temperature is always remain constant. That is called the Wien's displacement constant. That is called the Wien's displacement constant. Okay. Now see, I give you a question. एक क्वेश्चन आया था कि a black body at 1327, a black body at 1327 degree centigrade emits maximum energy corresponding to a wavelength 300 micrometer. Find the temperature of the moon for which the wavelength lambda is 6 micrometer. Try this question. The value of this Wien's displacement constant is 2.89 into 10 to the power minus 3 meter Kelvin. 2.89 into 10 to the power minus 3. So if we use this, see, that temperature must be in Kelvin scale. Okay. So 3 micro means 10 to the power minus 6 into 1320, that means 1600 Kelvin equals to 16 micro into T. So micro cancel, 16 cancel. So T is 300 Kelvin, T2 Kelvin, that means 27 degrees centigrade. So this is the answer. So that's it for the transformation of heat. Next, what was it? अब देखो, next is some basic topic related to heat and temperature. Like first of all, for temperature depend on the temperature is directly proportional to the length. That is called the temperature scale. So if you want to find out any temperature scale, so they are related like temperature is A L plus B, means temperature is directly proportional to length. A and B are constant. Actually, it is the equation of y equals to mx plus c. Whenever any equation is linearly dependent, they follow the equation of a straight line. So at 0 degree centigrade, if we write AL0 plus B, and at 100 degree centigrade, we write AL100 plus B. From this two, we can say 100, that is equals to A L100 minus L0. So A is 100 by L100 minus L0. And if we put this value, then or else we can say B equals to minus AL0. Now for any temperature T, that is A is 100 by L100 minus L0 into L, plus B is minus A, that is 100 by L100 minus L0 into L naught. From that, one thing is very clear: L minus L naught, L100 minus L naught into 100. That is my temperature at an instant. We can use this temperature for different scale. Like I just want to show you one scale. A question is that a platinum resistance thermometer. So it's the same way as the temperature depend on pressure linearly. So you can write P minus P naught, P100 minus P naught into 100. That is my pressure thermometer. For resistance, we can use R minus R naught, R100 minus R naught into 100. That is my resistance thermometer. So similarly, a question is there: a platinum resistance thermometer reads 0 degree centigrade. At 0 degree centigrade, resistance is 80 ohm. Okay, and 100 degree centigrade and 100 degree centigrade, its resistance is 90 ohm. At 100 degree centigrade, the resistance is 90 ohm. 90 ohm. Find the temperature at which the platinum at the platinum scale at which the resistance is 86 ohm. So find the temperature when the resistance is 86 ohm. Try this question. Hello. So that we can use temperature at any scale, that is resistance thermometer as we use. So 86 minus 80 by 90 minus 80. তোদের কি নিটের কি ডেট কি দিয়ে দিয়েছে? হ্যাঁ রে,
হ্যাঁ স্যার।
কবে থেকে পরীক্ষা?
কবে থেকে না, একদিনই, 12 সেপ্টেম্বর।
মানে এটা কি মানে শিওর ডেট পাবলিশ হয়ে গেছে?
হ্যাঁ, এটা অফিশিয়ালি।
আচ্ছা ঠিক আছে, আমি দেখি কালকে থেকে তোদের রাত্রিবেলাই পড়াবো, 9টা থেকে 1 ঘন্টা করে পড়ি। আচ্ছা দেখ, এরপরে আরেকটা জিনিস আছে যেটা আজকে আমি পড়াতে চাইছি, বাকি তো নেক্সট দিন পড়াবো। সেটা হচ্ছে আরেকটা জিনিস, থার্মোমিটারে কি হয় যে এনি টেম্পারেচার স্কেল মাইনাস লোয়ার ফিক্সড পয়েন্ট বাই আপার ফিক্সড পয়েন্ট মাইনাস লোয়ার ফিক্সড পয়েন্ট ইজ ইকুয়ালস টু কনস্ট্যান্ট। ঠিক আছে, এবার এখানে দেখ যদি আমি সেন্টিগ্রেড স্কেল নিই, তাহলে সেন্টিগ্রেড স্কেলে লোয়ার ফিক্সড পয়েন্ট হচ্ছে আপার ফিক্সড পয়েন্ট, লোয়ার ফিক্সড পয়েন্ট হচ্ছে 0 ডিগ্রি, আপার হচ্ছে 100। যদি আমি ফারেনহাইট স্কেলে যাই, তাহলে লোয়ার ফিক্সড পয়েন্ট হচ্ছে 32 ফারেনহাইট, আপার ফিক্সড পয়েন্ট হচ্ছে 212 ফারেনহাইট। যদি আমি ক্যালভিন স্কেলে যাই, এটা হচ্ছে গিয়ে 273 ক্যালভিন অ্যাপ্রক্স, এটা হচ্ছে 373 ক্যালভিন। এই দুটোই হচ্ছে ইটস ডিপেন্ড অন melting of ice, that is the lower fixed point, and boiling of water, that is the upper fixed point. Suppose a new scale is there, Shom scale, where suppose the lower fixed point is 50 Shom and upper fixed point is suppose 250 Shom. So examiner can give you, here the difference is 100, here the difference is 180, here the difference is 100, here the difference is 200. Examiner can say you, convert any scale into any other scale, like they can give you like a new scale is found in suppose Harappa civilization, where the lower fixed point is 50, upper fixed point is 250. Find the temperature in that new scale, so you can find out in that way also. So that centigrade scale jodi hai C minus 0, so the difference is 100. Fahrenheit scale F minus 32 by 180. For Kelvin scale K minus 273 by 100, and for Shom scale suppose S minus 50 by 200. So what we have, C by 5, F minus 32 by 9, that is K minus 273 by 5, that is S minus 50 by 10. So you can convert any scale into any scale. Suppose examiner can ask you what is the temperature for Fahrenheit scale, for what temperature Fahrenheit scale and Shom scale are equal. So we can write X, let X is the temperature, X minus 32 by 9, that is X minus 50 by 10. So you can write this 10X minus 320, that is 9X minus 450. So X is equals to minus 450 plus 320, তাহলে কতগুলো 30 40 50 30 40 50 20 30 40 50, then 130 centigrade scale and sorry, Fahrenheit scale and Shom scale are equal. Is it clear? Same way they can give you key, suppose 50 degree in centigrade scale is how much equals to in Shom scale. So S minus 50, that is 100, so S is 150 Shom scale. 50 degree centigrade scale equals to 150 Shom scale. They can ask you this type of question. Acha. Apart from that, you have linear expansion, 3 type of expansion. One is called the linear expansion. In linear expansion, change in length directly proportional to initial length into change in temperature. So that L minus L naught, when you take a constant alpha L naught del theta, so L naught, L equals to L naught 1 plus alpha del theta. Similarly, for area, you can write A naught 1 plus beta del theta. Similarly, for volume, you can write V naught 1 plus gamma del theta. Now, if you want to find out the relation, alpha is to beta is to gamma, that is 1 is to 2 is to 3. So this one is very useful. अच्छा, हर एक जगह पे यहाँ पे ये दे सकते हैं, alpha is the coefficient of linear expansion, that is change in length by original length into change in temperature. What do you mean by beta? Change in area by original area into change in temperature. What do you mean by gamma? Change in volume by original volume change in temperature. So alpha is called the coefficient of linear expansion, beta is called the coefficient of superficial expansion, and gamma is called the coefficient of volumetric expansion. अब देखो इसके ऊपर कुछ छोटा छोटा क्वेश्चंस होता है, like if I say a pendulum, T is the time period, that is 2 pi root under L by G. So if we say the temperature at any instant and the temperature at 0 degree centigrade, so what we have L by L0, that is L naught 1 plus alpha del theta by L naught. L naught cancel. So we have 1 plus alpha del theta half. Now alpha, beta, gamma, they are very small value, very less than 1. So we can use the binomial theorem 1 plus half alpha del theta. So t by t naught minus 1, that is half of alpha del theta. So t minus t naught by t naught, half of alpha del theta. That is the lose or gain of time period per second. और अगर हमें del t चाहिए, that is time loss or gain overall, that is alpha del theta into t. Okay. Total loss of time period ये है loss of time period per second और ये है total loss of time period. ठीक है, एक छोटा सा क्वेश्चन है. The question is like a pendulum clock consists of an iron rod connected to a small heavy bob. It is designed to keep correct time at 20 degrees centigrade. 20 degree पे correct time show करता है. ठीक है. How fast or slow will it go in 24 hour at 40 degrees centigrade? 40 degrees centigrade 24 hour. एक चीज देखो, if the temperature increase, then the length will increase. When the length will increase, time period increase. Time period increase means the time will slow. Length decrease, time period decrease, then the time will fast. So तुम्हें क्या करना है, यहाँ पे del t निकालना है. अच्छा, here it is given the coefficient of linear expansion for iron rod is 1.2 into 10 to the power minus 5 per degree centigrade. So what do you mean by alpha? Alpha देखो यहाँ पे everything is given half alpha del theta into total time. So half 1.2 into 10 to the power minus 5. Change in temperature 20 and total time period is 1 day. That is 24 into 3600. When you calculate this, you get almost 10.4 seconds. So time is fast or slow. So as the temperature increase, so time will slow. In 1 day, 10.4 seconds slow. Clear everyone? Is it okay? Is it okay? हेलो. अच्छा, इसके बाद देखो एक और है कि अगर मेरे पास ऐसे करके 2 सपोर्ट है और यहाँ पे एक मैंने रॉड रखा है. इफ आई एम गिविंग हीट, सो ये क्या करेगा, एक्सपेंड होगा. सो एज ये एक्सपेंड होगा तो ये फोर्स लगाएगा. सो इफ आई हैव टू फाइंड आउट दिस फोर्स, मुझे मालूम है y क्या होता है, यंग्स मॉडुलस स्ट्रेस बाय स्ट्रेन. स्ट्रेस क्या होता है, स्ट्रेस होता है फोर्स पर यूनिट लेंथ. स्ट्रेन क्या होता है, चेंज इन लेंथ बाय ओरिजिनल लेंथ. अब मेरा चेंज इन लेंथ क्या है, चेंज इन लेंथ है L अल्फा डेल थीटा. सो फोर्स पर यूनिट एरिया force per unit area by L alpha del theta by L cancel. So force by area alpha del theta. So मेरा force कितना हो गया, y a alpha del theta. ये मेरा force हो गया. देखो एक क्वेश्चन है इसके ऊपर. क्वेश्चन इज एकदम क्वेश्चन सब एकदम पुट द वैल्यू वाला क्वेश्चन है. A steel wire cross sectional area, steel wire cross sectional area 0.5 millimeter square is held between two fixed support if the wire is just taut at 20 degrees centigrade. हेलो. हाँ मैम. यस मैम. tomorrow at 3:30 स्कूल में आने के लिए कुछ क्लास तो मेरा 1:30 बजे तक है, कोई विशेष काम है क्या? ओके ओके ओके, this is too much. Area, this one, temperature 20 degrees centigrade. Determine the tension when the temperature falls to 0 degrees centigrade. When the temperature falls to 0 degree centigrade, coefficient of linear expansion of steel 1.2 into 10 to the
স্যার এই চ্যাপ্টারটা কি থার্মাল প্রপার্টিজ?
হ্যাঁ,
আর থার্মোডাইনামিক্স এর ক্লাসটা কি প্রথম দুদিনে শেষ ছিল?
হ্যাঁ থার্মোডাইনামিক্স হয়ে গেল তো, থার্মোডাইনামিক্স হয়ে তোর এটাও তো শেষ হয়ে গেল, কন্ডাকশনও হয়ে গেছে। এটা হচ্ছে ওই যে থার্মাল, এই যে থার্মোমিটারের কোশ্চেনগুলো।
হ্যাঁ, আর থার্মোডাইনামিক্স এর কোশ্চেন মানে ওইটা কবে অবধি শেষ হয়ে গেছিল? প্রথম দুদিনে না?
হ্যাঁ হ্যাঁ, এই যে তোর সেকেন্ড ল করলি না,
হ্যাঁ ওইটা অবধি তো।
তোরা কোশ্চেন করিস, ডাউট হলে বলিস আমাকে। Alpha is 1.2 into the minus 5 per degree centigrade and Young's modulus is given. 2 into 10 to the power 11 Newton per meter square. So how you find out the force? See, everything is given. 2 into 10 to the power 11 cross sectional area 1/2 into 10 to the power minus 6 alpha 1.2 10 to the power minus 5 and change in temperature 20. So basically what happened, this cancel, half of cancel, so 1.2 into 20, that is 24 Newton. Okay, so